So we're looking at factoring by grouping notes today, and our learning target is that we can factor a quadratic using the strategy of factor by grouping. When we look at a quadratic in standard form, the standard form of a quadratic is y equals ax squared plus bx plus c. This is also called a trinomial because it has three terms. So we have the ax squared term, the bx term, and the c term. When we graph parabolas, it's helpful if we can get them into intercept form. So intercept form, which we're going to be beginning to work with, is y equals a times the quantity x minus p times the quantity x minus q, where p and q are the roots. So the method that we are going to use, and your high school teachers have specifically asked for Algebra 1 students to be taught with this method, because it is a method that's going to be really helpful for you in Algebra 2 and pre-calculus and calculus. So there are lots of really good ways to factor trinomials. But when we're doing factoring by grouping, we're just going to use this strategy, and it's just consistent with what your teachers at LHS will use. That does not mean it's the best strategy or the only strategy. There are definitely other strategies, but this is just a convenient one that we want to make sure everybody knows how to factor this way. Can you learn other ways? Absolutely, but I want to make sure that you know how to factor by grouping, and we're going to use the X method. Okay, so what we're going to do is start off by making a large X. Okay, and then in that X, in the top portion, we're going to put ax squared times c. So that's going to be our first term times our third term. So in this trinomial, that's going to be 3x squared times 4. Well, what is 3x squared times 4? 12x squared. Okay, in the bottom of the x, so this portion, we're going to put the bx, which is the middle term, including its sign. So that's a positive 8x. Okay, I don't need to write the positive, but if it were a negative, I would write the negative sign. Okay, so now step 3, we need to determine the factors of ax squared times c, okay, that add up to 8x and multiply to 12x squared. Okay, well, if you're really strong with your math factors and you're great at, these are both positives, but some of the assignments or some of the problems that we'll do will have negatives. So I'm going to show you a strategy that if you're not super great with your math facts and factoring, it's just going to help you. So 12x squared. Okay, so that's our number that it has to multiply to. Okay, so that's the 12x squared. So I'm putting it here. And then to help us to see which ones add up to 8x, and some of you will be able to do these in your head, and that's fine. Some of you are going to want the t-chart over here to help you, and that's fine. I do find that kids make fewer mistakes with the negatives when they use the t-chart over here for the factors, okay? So what are the factors that I can multiply together to get 12x squared, okay? So I can multiply x times 12x, so that's 1 times 12 is 12, x times x is x squared. 2x times 6x would multiply together to give me 12x squared. And 3x times 4x would multiply together to give me 12x squared. So then so that takes care of this part. I listed all the possible factors. So then I want to find which two will add up to 8x squared. Oh, well, 2x and 6x will add up to 8x. So the 2x and the 6x will go in the left and right side, and that's arbitrary which one you put where, the left side and the right side of the x. So now what we're going to do is we're just going to take our trinomial and we're going to rewrite it, except instead of rewriting the 8x, we're going to substitute our 8x with 2x and 6 plus 6x, because I can break that apart, the 8x, I can break that apart into 2x plus 6x, and that's going to make it factorable. So I'm rewriting my trinomial y equals 3x squared, but instead of having plus 8x, I'm going to say plus 2x plus 6x. Is 2x plus 6x equal to 8x? Yes. Have I changed the value? No. Then I bring down the plus 4. So now this is factorable, and this is the part where we're going to look at the factor by grouping. So we're going to break this into two smaller groups. The first group will be your first two terms. And again, if you had the 6x here and the 2x here, it will still work out the same way, but I tend to put the smaller absolute value 2 on the left and the larger absolute value 6 on the right, because I just copied them from my factor table there. Okay, so this first group is the first two terms, including their signs, and the second group is the second two terms, including their signs. So now what I'm going to do is I'm going to look at the first group. So I'm going to bring down my y equals. I look at my first group, 3x squared and 2x. What's the greatest common factor of 3x squared and 2x? Well, the only thing they have in common is an x. So I'm going to factor out an x from those two terms. And what am I left with? 3x squared divided by x is 3x. And 2x divided by x is 2. So it's plus 2. All right. Then I'm going to go to my second group. So I just factored the first group. This is why it's called factor by grouping. Now I'm going to factor the second group. Okay. 6x plus 4. What's the greatest common factor there? 2. So we'll say plus, because this is a plus, 2, which I'm factoring out of the second group. What is 6x divided by 2? 3x. What is 4? Positive 4 divided by 2? Positive 2. Now, if you did this correctly, and you will make some mistakes, okay? So when I'm doing my factor by grouping, I always take out my big eraser, okay? So, well, I have an erasable pen right now, but when I'm doing it in pencil, I always have my eraser. You're going to make mistakes, and that's okay. So if you did this correctly, these two terms that are left after you factored out your GCF will be the same. Okay, so what we did here was factor out GCF by group. Okay, so that's what we did here. The first group we factored out an x, the second group we factored out a 2. Now we're going to factor out a GCF from these two terms. So again, this is the first term, x times the quantity 3x plus 2. This is the second term, bless you, 2 times the quantity 3x plus 2. So now I'm looking at this as my first term, and I'm just going to underline that with just a pencil, so it's a different color. And this is my second group. Now, what can I factor out of those? What do they have in common? Well, they have 3x plus 2 in common. So now I'm going to bring down my y equals, and I'm going to factor out the 3x plus 2 from each of these terms. 3x plus 2. Okay, so when I go to my first term and I factor out the 3x plus 2, what's left over? X. And I look at my second term, when I factor out my 3x plus 2, what's left over? Plus 2. Okay, so now this is called factored form, and this is going to be helpful for us when we want to graph, okay, or solve for zeros to get our x-intercepts. So now, remember in math, every operation has an inverse operation. So I just factored. If I want to check this and make sure that I factored correctly, what would I do? I would distribute, right? We used to call this FOIL, binomial times a binomial, okay? But FOIL was very specific to a binomial times a binomial. So we don't really teach it as FOIL anymore, but you'll still hear it. And it's a useful strategy, but let's go ahead and just use the distributive property. So here's our check step. This is our answer. We want to check and make sure we factored correctly. So we have 3x plus 2, quantity multiplied by the quantity x plus 2. So y equals, I'm going to distribute 3x times x, 3x squared, 3x times 2, plus 6x. Then I'll distribute this positive 2. 2 times x plus 2x, 2 times 2 plus 4 This should match your first step. Okay, then we combine like terms. Y equals 3x squared plus 8x plus 4. That's our original quadratic. So that checks out. All right, and then I want to show you one more way that we can check our work here. And this is, so this you can do on any test, even a non-calculator test, okay? If you want to check it using Desmos, and I'm just going to get my shared screen so that you can see the Desmos. So we can come right over here to Desmos, just desmos.com. And again, this is not something that you can do on your test, but while you're practicing on your homework, you can check this with your graphing calculator. So our original equation was y equals 3x squared. And then right down here is your math keyboard. So 3x squared plus 8x plus 4, oops, not equals 4, plus 4. Okay, so that's the parabola graph by that equation. Then I'm going to type in my factored form. And so this is just another way that I can check my work without having to distribute. So in my factored form, we had y equals the quantity 3x plus 2 times the quantity x plus 2. Okay, and you can see if I turn one of these graphs off, I see the other one. So I just turned off the second graph and then I turned it back on. I'll turn off the first graph and then turn it back on. Okay, so you can see if they're the same graph, then we know that we factored correctly. Okay, so on the back page of the notes, factor each quadratic equation function or a function below. So let's take a look at number 1. F of x equals 2x squared plus 9x plus 9. So we want to make our x. And in the top, we're going to put the a times the c. So 2x squared times 9 is 18x squared. And in the bottom of the x, we want to put our middle term. That's the positive 9x. And we want to look for which two terms multiply together to give us 8x squared and add together to give us 9x. So I'm going to make a table of factors just as a visual aid. And some of you can do this in your head, and that's fine. If you can do it in your head, you do not need to make this list, but it is helpful. It eliminates some guess and check, especially when you get to the negatives. So the factors of 18x squared would be 1x times 18x, or 2x times 9x, or 3x times 6x. So which of those pairs will add up to 9x? Good. The 3x and the 6x. So those go on the left and right side of our x. So 3x and 6x. And it doesn't matter which one you put left or right. So then we're going to take that middle term, the 9x, and we're going to break it up into 3x plus 6x. So we're rewriting our trinomial as f of x equals 2x squared plus 3x, which is coming from here, plus 6x, which is coming from here. And then bring down the plus 9. Okay, now we're going to factor by groups. This is our first group, the 2x squared plus 3 term. And this is our second group, the 6x plus 9 terms. Okay, so let's look at the first group. Bring down the f of x equals. When I look at 2x squared plus 3x, the greatest common factor in this group is just x. All they have in common is x. So then I look at 2x squared. When I factored out an x, that leaves me with 2x. Then I look at plus 3x. When I factored out an x, that leaves me with plus 3. Moving on to my second group, I have plus 6x plus 9. So we'll say plus 3. That's what I can factor out. The GCF of 6x and 9 is just 3. Okay, and 6x divided by 3 is 2x. The positive 9 divided by positive 3 is positive 3, so plus 3. If I factor correctly, these two leftover terms after I factored out the GCF of x and this GCF of 3, these two terms will be equal. If they're not equal, 2x plus 3 and 2x plus 3, go back and double check. And we will look at an example that cannot be factored, okay? So now, great, we factored out our GCFs, that's our factor by grouping part 1. Now we'll factor out a GCF here. So f of x equals, now my first term is x times the quantity 2x plus 3. My second term is 3 times the quantity 2x plus 3. So what's the greatest common factor between these two terms? Well, they have in common a 2x plus 3. So I'm going to factor that out, 2x plus 3. Okay, now let's look at our first term. X times the quantity 2x plus 3. What's left over after I factored out the 2x plus 3? X. And then my second term is 3 times the quantity 2x plus 3. What's left over after I factored out the 2x plus 3? Plus 3. Okay, so in factored form, f of x equals 2x squared plus 9x plus 9 can be rewritten as f of x equals 2x plus 3 times the quantity x plus 3. And I can check this by distributing, okay? Or if it's not a test, I can check this by using decimals. So I would practice becoming very comfortable with using the distributive property to check these, okay? And then you can also double check it on decimals, but be comfortable with checking your factored form using the distributive property so that when you have your test or quiz that's non-calculator, you'll be able to know that you have it correct. All right, moving on to number 2. So we have f of x equals 2x squared minus x minus 10. I'm just going to slide the camera over a little bit. There we go. Okay. So I'll make my x a times c. So 2x squared times negative 10 gives me negative 20x squared. And then my b term is negative x. And if you want to write the coefficient 1, that's sometimes helpful just for visualizing, negative 1x. I'm going to write that a little neater. Okay, so now I'm going to go ahead and look at my my top of my x. So I have negative 20x squared. And I'm just going to come back to the negatives in a moment. Right now, I'm just going to look at the absolute values. So I can say 1x times 20x. I can say 2x times 10x. 3 does not go evenly into 20. I can have 4x times 5x. Okay. Now let's talk about our signs. And this is why the table is helpful. It is a little bit more work right up front. It's not hard work, okay? But it helps us with the negatives. So our two numbers have to multiply together to give us negative 20x. In order to multiply together to give us a negative, we know that one of them has to be positive and one of them has to be negative, okay? So one will be positive, one will be negative. When I add them together, my answer is going to be negative 1. So I know when I add a positive and negative value together, in order to have a negative answer, the number that has the larger absolute value has to be negative, which would be these numbers in the right-hand column because we listed them in an ordered way. So these would be the ones that would be negative, and these would be the positive options. So which of these add up to negative 1x? Well, positive 4x and negative 5x would add up to negative 1x. Okay, so sorry, that negative, I wrote it right on the line, so it actually looks like a positive. Let me put that in a different spot. So negative 5x and positive 4x. And we know that negatives are bigger than or smaller than positives, but I'm just going to list them from my table here. So 4x, and it doesn't matter if you put them in a different order, but when you look at my answer keys, they'll be in this order, but both ways will work. So positive 4x and negative 5x. So now all I'm going to do is I'm going to rewrite my trinomial, but instead of saying minus x, I'm going to say plus 4x minus 5x. Okay, and that does not change the value because guess what? 4x minus 5x equals negative 1x. Okay, but that's going to allow me to factor by grouping. So I'm rewriting my trinomial as f of x equals 2x squared. And again, instead of minus x, I'm writing these two numbers, plus 4x minus 5x. And then bring down the minus 10. Now I can factor by grouping. My first group is 2x squared plus 4x. My second group is negative 5x minus 10. Okay, so f of x equals, let's factor out the GCF of the first group. What is the GCF of 2x squared and 4x? Well, the GCF is going to be 2x. They have a GCF of 2 for the numerical part, okay, and an x for the variable part. So I'm factoring out a 2x. 2x squared divided by 2x is x. 4x divided by 2x is 2. So we have x plus 2. So that first group is factored. Now I'll go to the second group and I'll factor out the GCF of the second group. Negative 5x and minus 10 or negative 10, they have a GCF of negative 5. We want to factor out the negative when we can. No variable because that's just a 10, not a 10x. Okay, so negative 5x divided by negative 5 is x. Negative 10 divided by negative 5 is positive 2. Now I'm going to stop and pause. Do these two match? Yes. Okay, x plus 2 is left after I factored out the GCF in the first group. X plus 2 is left after I factor out the GCF of the second group. Okay, so then f of x equals, I can factor out the x plus 2 because both groups have that in common. And then what's left after I factored out the x plus 2? 2x minus 5. And we can check that by using the distributive property. We can check it with Desmos. We can check it with the graphing calculator. Okay, moving on to number 3. F of x equals negative 3x squared plus 10x plus 8. So we'll make our large x, a times c, negative 3x squared times positive 8x is negative 24x squared. Our middle term is 10x. Okay, so we want to see what goes on our left and right side of our x here. So let's list our negative 24x squared and the different possible factors. I can say, and I'll come back to the negatives in a moment. Okay, so right now I'm just looking at the values. 1x and 24x, 2x and 12x, 3x and 8x, 4x and 6x. So we know they need to multiply together to give us negative 24x squared. So we know one column is going to be positive, one column is going to be negative. And they need to add up to a positive 10x. So if they add it up to a positive value, then we know that the numbers on the right-hand side have to be positive because there were more positives than negatives. That's how we ended up with a positive sum. So that tells us that the left-hand side would be the negative choices. Okay, so which of these are going to add up to positive 10x? Positive 10x? Well, negative 2x plus 12x. So negative 2x and positive 12x. Okay, so now I'm just going to rewrite my trinomial. F of x equals negative 3x squared. But instead of saying plus 10x, I'm going to break it up into those two factors. Minus 2x plus 12x. And then bring down the plus 8. And I'm just going to slide this negative 2x over a little bit so it's not running into my my groups here. So then f of x equals, let's factor by grouping. Okay, so I look at negative 3x squared and negative 2x. I want to factor out the negative and I want to factor out the x. So negative x And then when I factor out the negative x, I'm left with 3x plus 2. Okay, then I come over to my second group. What's the GCF of 12x plus 8? Well, that's a positive 4, so we'll say plus 4. And then when I factor out a 4 or divide out a 4, I am left with, well, 12x divided by positive 4 is 3x. 8 divided by 4 is 2. So we have the 3x plus 2. Okay, then if I factored correctly, these two will be equal, which they are. So f of x equals, I'll factor out that 3x plus 2 from this term and from this term. So 3x plus 2. And then what's left over? Negative x plus 4. And then I would check this by using the distributive property. Okay, and then if it's just for your homework, you can check it with Desmos just to kind of make sure you're not taking too long, but knowing how to check with that distributive property is really important. Okay, number 4. X squared times 12 is 12x squared. And then our middle term is 7x. Okay, so let's list our factors of 12x squared. So we can have 1x and 12x, 2x and 6x, 3x and 4x. Okay, and then which of these are going to add up to 7x? Good, 3x and 4x. So now I'll rewrite my trinomial, but instead of saying plus 7x, I'll say plus 3x plus 4x. So f of x equals x squared plus 3x plus 4x, and then bring down the plus 12. Okay, and if it helps you to draw arrows, like, hey, where are these numbers coming from? They're coming from our factored x over here. Okay, so now I can factor by grouping. Here's my first group. Here's my second group. So f of x equals x squared and 3x have a GCF of x, which leaves us with x plus 3. Then I go into my second group, 4x plus 12. They have a GCF of 4, so I'll factor out a 4, which leaves me with x plus 3. Okay, these both have an x plus 3. If they don't, go back and take a look, double check your work. Okay, then I'm going to factor out the x plus 3 from each term, which leaves me with the quantity x plus 4. Okay, and then if you're checking these with the distributive property, awesome. If you're checking these as you go with Desmos, also awesome, by the way, but you'll start to notice that these are your zeros. This is where your parabola will cross the x-axis. So here, our parabola will cross the x-axis at -3 and -4. Because when we set these equal to 0 and solve, remember we branched those off into the two different possible solutions using the zero product property. So this will cross the x-axis at x equals -3 and x equals -4. And that'll be helpful when we're graphing. So that's just a little note. Put a little asterisk there. All right, moving on to number 5. A times C will give us -7x squared, and our B term is -5x. Okay, so we can have 1x and 7x, and that's all. Okay, because 7's a prime number, it only has factors of 1 in itself. Okay, positive or negative, is there any way that this can add up to -5? No. Okay, so if that's not possible, this cannot be factored. Okay, so this cannot be solved by factoring. And we will learn about the quadratic formula, which is going to be a method that we'll use for these trickier problems. So for now, we're just going to say cannot be factored or cannot be solved by factoring. Okay, so again, how did we know that could not be factored? Okay, we listed our AX, or excuse me, our AC, negative 7x squared, in the top of our X, our B term, negative 5x here, in the bottom of our X. Okay, our only factors of negative 7x squared would be X and 7x. Okay, positive or negative, there's no way that these can add up to negative 5x. Okay, so this cannot be factored. Okay, moving on to number 6. F of x equals 10x squared minus x minus 2. Okay, 10x squared times negative 2 is negative 20x squared, and our B term is negative 1x or negative x. Okay, so let's list our factors of negative 20x squared. Okay, 1x and 20x, and we'll come back to the signs at the end. That's a little too close together. Let me space that out nicer. 1x. Okay, so we can have 2x times 10x. 3 does not go evenly into 20. 4x and 5x. Okay, when we multiply these together, they multiply to negative 20x squared. So we just listed all the factors. Okay, broke out all the possible division problems or multiplication problems, I mean. Then we want to see which will add up to negative 1x. Okay, well, if when you add them together, your answer is negative, okay, which it is, that means we had more negatives than positives. That means that the larger values, the 20x, the 10x, the 5x, these would be the negative choices. The smaller values would be the positive values, because when we add them together, we have more negatives than positives. So which of these sets, or which of these pairs of factors add up to negative 1x? Good, 4x and negative 5x. So we put those in our factoring x over here, 4x, negative 5x. And then we'll rewrite our trinomial, substituting that middle term, the minus x, with 4x minus 5x. Okay, so let's do that. F of x equals 10x squared plus 4x minus 5x. And then bring down the minus 2. Okay, then we'll factor by grouping here. F of x equals, okay, so look at 10x squared and 4x. What's the GCF of that group? 2x. Okay, so what's 10x squared divided by 2x? 5x. What's 4x divided by 2x? 2. Okay, what's the GCF of negative 5x minus 2? Just a negative 1. Okay, and you can write the negative 1, or you can just write the negative. I'll write the 1 in there because it's going to help us to see our second binomial. And then what's negative 5x divided by negative 1? 5x, that's positive. And what's negative 2 divided by negative 1? Positive 2. Okay, so then I check if I factored this correctly, these two numbers left over after I factored out the GCF of each term will be equal. 5x plus 2, 5x plus 2. So now I move on and I factor out the GCF of the first term and the second term. Okay, which is going to be obvious. It's the 5x plus 2. Okay, and then what's left over after I factor out the 5x plus 2? 2x minus 1. And if you didn't have the 1 there, it would be just the, it's still, you would need to write it here in the factored form. So f of x equals 5x, the quantity 5x plus 2 times the quantity 2x minus 1. Number 7. Okay, a times c gives us 8x squared. And our middle term is minus 6x. Let's list our factors of 8x squared. So be x, or excuse me, 1x and 8x, 2x and 4x. Okay, they need to multiply together to give me a positive, and they need to add together to give me a negative. Well, if they multiply together to give a positive, it's either a positive times a positive, which that can't be because a positive and a positive would not add up to a negative, or a negative times a negative will also multiply together to give us a positive. So we know it has to be a negative times a negative. That gives us our positive number in the top. And it has to be a negative plus a negative to give us a negative number in the bottom. So all of our choices are negative. Okay, and again, the way that I knew that was this. They multiplied together to give me a positive. They added together to give me a negative. So both of the numbers have to be negative. Okay, so which of these will add up to a negative 6x, negative 2x, and negative 4x? Okay, so then I'll break apart my trinomial. It's now going to be f of x, or break this middle term up into x squared stays the same, but instead of minus 6x, we now have minus 2x minus 4x. And then break down the plus 8. Now we can factor by grouping. First group, second group. Okay, so f of x equals, I look at my first group, x squared minus 2x, they have a GCF of x. And then what's left over after I factored out the x minus 2. Then I look at my second group, I'm going to factor out a negative, and then the GCF of 4x and 8 is 4. So I'm going to factor out a negative 4. Okay, negative 4x divided by negative 4 leaves me with a positive x. Positive 8 divided by positive 4, or excuse me, positive 8 divided by negative 4 leaves me with negative 2. Okay, so be very careful with your signs. X minus 2, great. Some of you might even want to pause and just check with the distributive property if you're not really strong with your negatives. At this point, check this. These are positive, so that's a little easier. Okay, so then we factor out the GCF of these two terms. F of x equals, well, they have an x minus 2 in common, so we factor that out. And then what is left is x and minus 4. So x minus 4. And then you can check that with the distributive property. Check by distributing. Okay, number 8. And then, oh, this one's a little different. So this doesn't have the middle term listed, and that really tells us, so this is a perfect square, the 16 and the x squared. So that middle term canceled out. So if you were to have written this with your in standard form, we would write this as f of x equals x squared plus 0x minus 16. You're going to kind of get to know this is going to be factored out as f of x equals, when it's negative, it's going to be x minus 4 and x plus 4. Okay, but let me show you how that works out, even if you do the factor by grouping. So you have a strategy that always works, but you'll begin to recognize this right away. It's a perfect square. Okay, so I'm just going to erase this. And we're just going to use that same method, factor by grouping, recognizing that our b term is 0. So our b term is going to cancel out. And I'm going to slide this over a little bit, sorry. So our b term is going to cancel out. Okay, meaning like we have a positive 4x and a negative 4x basically. But let's show that algebraically. So AC is going to be negative 16x squared, and our b term is 0x, meaning these two are opposites. Okay, they add up to 0x, or they add up to 0. Okay, so then I'm off of the screen, hold on. Okay, so negative 16x squared, 1x, and 16x, that's not going to add up to 0. 2x and 8x, that's not going to add up to 0. 4x and 4x, okay. knowing that they have to multiply to a negative and add up to a 0, we know one of them has to be positive and one of them has to be negative. And it doesn't matter which one you write where. So negative 4x and positive 4x. Okay, so then we would have f of x equals x squared minus 4x plus 4x, and then bring down the minus 16. So you see that then negative 4x plus 4x, they add up to that 0x. So we can still factor by grouping, but you'll memorize this and you'll recognize the perfect square as you do, as soon as you kind of have a few practice problems. So our first GCF is x, leaving us with x minus 4. Our second GCF is a positive 4, leaving us with x. Negative 16 divided by positive 4 is negative 4 or minus 4. Okay, so then we see that they have the GCF of x minus 4. And then when we factor that out of the first term, that leaves us with x. And when we factor that out of the second term, that leaves us with plus 4. Okay, and then when you distribute, you'll see that simplifies to f of x equals x squared minus 16. And it is okay with me if you recognize these are perfect squares, x squared and negative 16. Okay, when there's a negative, one of the x4s will be positive, one of the 4s will be negative. Okay, so that is quite a few sample problems on factoring by grouping.